This is USACO 2020 January Contest Silver, Wormhole Sort. Farmer John's cows have grown tired of his daily request that they sort themselves before leaving the barn each morning. They have just completed their PhDs in quantum physics and are ready to speed things up a bit. This morning, as usual, Farmer John's N cows, conveniently numbered 1 to N, are scattered throughout the barn at N distinct locations, also numbered 1 to N, such that cow I is located at PI. But this morning there are also M wormholes, numbered 1 to M, where wormhole I bidirectionally connects location AI with location BI, and has a width of WI. At any point in time, two cows located at opposite ends of a wormhole may choose to simultaneously swap places through the wormhole. The cows must perform such swaps until cow I is at location I for 1 is less than or equal to I and is less than or equal to N. The cows are not eager to get squished by the wormholes. Help them maximize the width of the least wide wormhole which they must use to sort themselves. It is guaranteed that it is possible for the cows to sort themselves. And first we need to read the input. The first line contains two integers, n and m. The first line contains the n integers p1, p2, p to pn. It is guaranteed that p is a permutation of 1 to n. For each I between 1 and m, the line I plus 2 contains the integers a, b, and w. So in this sample case, there are 4 cows. Cow number 3 is at location 1, cow number 2 is at location 2, cow number 1 is at location 3, and cow number 4 is at location 4. There are also four wormholes. The first one connecting place 1 and 2 and has a width of 9, the second one having the width of, or connecting 1 and 3 and having the width of 7, the third one connecting 2 and 3 with a width of 10, and the last one connecting 2 and 4 with a width of 3. And the output format is just the maximum minimal wormhole width, which a cow must squish itself during the sorting process. And if the cows do not need any wormholes to sort themselves, or in other words, it's already sorted, we need to output -1. For this sample case, the minimal or the maximum minimal wormhole width is 9. And the way to approach this is by using binary search to find the minimum wormhole size, then using DFS or BFS to find all connected groups of the cows. And this is important because this is just like kind of a rule, or you should just know this. If a group is connected and it can move freely in between, any permutation within that group is possible. So 1, 3, 2 means that it can also be 2, 1, 3 or 1, 2, 3. And this means that as long as the connected components include itself in the initial position, that specific group is set to be sorted for the final after a certain amount of permutations. And this will be more evident when we code this later on. So let's get to the coding part. This is the code, and I have already coded the entire problem out, and I will go through each of the steps one by one. This is the method in which I read all of the input, and init is an integer array in which I store the initial order of the cows. This is important when this is important later, so we'll take a note of it. Holes is a hash map of all of the different wormholes. And I read this through this, and we have created a custom class for this, and it has an integer that represents which hole the wormhole switches, and size, the size of the wormhole. And we solve this by first using BFS to find all of the connected components. And this part finds the connected component, and after it finds it, it loops through the list of the connected components. And if the position of each connected component on the initial order of the cows are not contained by the connected component, it will not work. So we'll return false. And if it does work, for all of these components, we'll return true. And we can just implement this in the BF and before in binary search of all the sizes, and we can check if check works with the size. And then of course set the answer to mid, low to mid plus 1 since we're checking for a higher value, since if it does work, and high equals mid minus 1 since we're checking for a lower value if it does not work. And here we're checking if the initial order is already sorted, because in that case we'll need to print -1. And we'll check if this code works. As you can see, the code works, and that's all for this video.